Alright guys, we'll continue. So right, okay, so next lesson then, principle of moments. Please, do you write this down? Yep. Okay. Right, so look at this. So, I know, it's amazing. What would happen if equal but opposite forces applied at the end? So for example, here it is here, and we have force here F and force here F. What would happen? No, what would happen? It would start to turn, wouldn't it? Start to move, right? But you know, the force going up is F. The force going down is F. So the total is 0. So this is what you were saying, Mir. Well, maybe it doesn't move because this equals this. But then, as you were saying, but it will rotate.
Yeah.
So when you're looking at something, okay, just because this equals this, that doesn't mean nothing will happen. It depends where it is. So for example, if there's one here and one here, then it will turn. Yeah. So, well, let's see. So it would seem that the wooden plank should not move, but it does. So what's the story? Well, the plank is moving, it's rotating, so a turning force is making it turn. If it's not turning, then it would be in equilibrium. So this is the key idea I'm getting to, this idea of equilibrium. An object is in equilibrium. Now wait, wait, before you write it down. An object is in equilibrium if the total force is 0. So what I mean by that is if the up force equals the down, the left equals the right, and the force that makes it turn this way equals the force that makes it turn the other way, then everything is balanced. It's not moving. So that's what I mean by equilibrium. I mean everything is balanced. Therefore, the forces to the left equal the forces to the right, the forces up equal the forces down, and the turning force clockwise equals the turning force anti-clockwise. So now you can write it down. And of course, you know these words.
Yeah.
So this way is clockwise, and this way is anti-clockwise. Okay, so you can write this down now. Okay, you have this? Yeah. So really it's the box that you need to write down. Equilibrium means the total force is zero, therefore left equals right, up equals down, and then clockwise equals anti-clockwise. Okay, you have that? Right. The last point, in fact, this last one here has a special name. It's called the principle of moment. In fact, well, I don't really think it's exactly that, but it doesn't really matter. I should really say conservation of moment, maybe, but it doesn't matter. It's not so important. Okay, so again, if you want, you can try and draw it. First word you won't know is a seesaw, maybe. What's a seesaw? You know seesaw. Oh, you do know seesaw. Boy sits here, girl sits here, and then seesaw. Yeah. Huh? The game at the playground. Yeah. Okay, so what I want you to do is to try and draw this, or you can write it if you don't want to draw it. You'll draw it, okay. I thought so.
Means he wanted to make it balanced?
Yeah. So if the boy is 40 and the girl is 30, then it's not balanced because it will move with the boy.
So the boy will be up.
No.
It will be down and the girl is up.
Okay, did you draw this?
So.
Nearly. Yes. So the 5 meter seesaw is here. So this is 2.5. 2.5.
So it's all 5.
It's all 5, yeah. Right, shall we draw this? So what you have, here's the boy, and then here's the girl, and it's not balanced because he'll have, what did I say, he was 40 G, 40 times 9.81, and she's 30 G. So will it turn clockwise or anti-clockwise?
Clockwise.
Why?
Yep.
Why 50 grams?
No, not gram. 30 gram would be a problem. G, 9.81. Yeah. Someone else said that last time as well. W equals mg. This is the mass, and this G is 9.81. Yeah, that would be a small girl for 30 grams. Yeah. Now, which way did we say it will turn? This way. So what does the father do?
So the boy.
He moves this.
So the
Yeah.
boy will be down and the girl will be.
Well, no, to keep them balanced. So he'll put it like here, for example. Now you know that the total is 5, yeah. The total is 5 meters. Okay. I haven't drawn all the forces. Which force am I missing? I didn't draw. What did I not draw?
Something
The
about
seesaw.
100 kilos.
Yeah, the seesaw is
100 kilograms.
100 kilograms, so 100 times 9.81. That's the weight. And what else did I not draw? I left out one more force.
The reaction.
Very good. The reaction here So there are 4 forces. If this distance here is x, then how much is it from here to the girl?
Y minus X.
If that's x, how much is this one?
X plus Y.
5 minus X.
5 minus x. Right. What is the force going up? What force is going up? Yeah, so or. And what force is going down? 40g plus 100g plus 30g. Yeah? Which is 170g. Which is 1668 newtons. Okay. Now that's not what I want. I think in the question I asked you for the x, how far does the father need to move it? So I really want to know what the x is. So what can I use now? I can use the turning force. Yeah? This is my turning point. I'll take it here. So you have how many turning forces? 3 actually. This one, and this one.
Okay, why is this the between?
Why do we not count the or? Why don't we care about the or?
Because it's not having.
There is no reaction on.
No.
It's not at the same.
No.
time.
Come on, why is the or not important? I said it earlier with the door.
Oh, it's the Y.
Yeah, we don't care about the or because it goes through the turning point. It doesn't make it turn. Only these make it turn. The or doesn't make it turn. It doesn't. It doesn't do anything. So, which way will this turn? Clockwise or anti-clockwise? This one is anti-clockwise. This one clockwise, and this one clockwise. So this one should equal this one plus this one. Right, so we have 40g multiplied by x, because it's the force multiplied by the distance. Remember the formula? That should equal, now, who can tell me this distance here?
It's R minus 100 please.
What is this distance?
No.
Times 100g?
No.
What? What is
We're
it?
talking about the distance.
Yeah, from here to here. What is it? Oh, someone should know.
R minus 5 minus X.
What's the distance from here to here?
2.5.
2.5. What's the distance from here to here? X. So therefore,
X minus 2.5.
the other way,
2.5.
2.5
Okay, why?
minus X.
Why the distance between the boy and the?
Oh yeah, why is it 2.5?
Yes.
The weight is in the middle. It's the center. Yes. Okay. And then what about from here to the girl? What's that? 5 minus x times 30g. Okay? So this is the turning force of the boy. This equals the turning force of the seesaw plus the turning force of the girl. Because this one makes it turn that way, and these one make it turn this way, and they should be equal. So now you have 2 equations and 2 variables, or and x. I don't care about the or, but I know it, so I just need to find the x. So that's okay. Let's just put in some numbers. 40 times 9.81, so we get 392.4x equals, yeah, the next one would be 2452.5 minus 981x plus 1471.5 minus 294.3 x. So I just took this and expanded. Now this is very easy to solve. What type of equation is this called? It's a linear. You know how to solve this, right? I don't need to show you how to solve this, I hope.
Then
You put the x on this side and the numbers on this side.
maybe you will remember.
Alright. Go ahead, Mir, what do I do? I'll
X
put
on
the
left
x's on the left
and the numbers on the right.
and then the numbers on the right. The non-x.
And you
Yeah.
add the axis
Yeah, yeah,
together.
Don't, it's too late now, you can't pretend like you knew it. Okay.
I do know.
Oh, great. So, I don't need to show you anymore. Can I just... Alright, okay. Yep. So the x is a bit bigger than I thought, but the father doesn't need to move it too much because they're not too different in weight, I suppose. 2.35 meters. So remember, originally it was here in the middle at 2.5 and 2.5. So then the father moves it so that it's now 2.35 and then well, the other half would have to be 6.5 then. So he moves it to the left to balance the seesaw then. Okay. So this is, type of exam question. Maybe a little bit easy, but not too different.
Pull it up.
Zoom out more.
Yeah.
Okay. Are we good like with here? We have to be, don't we? Okay, so write that down. Yeah, don't take your head off. You'll break your neck. This is what he's worried about. Then we'll have to clean up the mess. Okay, you have this. Yeah. Oh yeah, quick check of vocabulary. So here, this point right here, what did we say this one's called?
Turning point.
Well, sorry, I should be a bit more clear. The turning point's actually here, Mayor. So this, the center of gravity is this one here, which we said last time. Okay, we have this. All right. Here? No, but I mean I could go, do you need the picture? It's ugly. Okay. Next one? Yep. Right, okay, so we have two more examples to do. This is a very typical exam question. Now, be careful. Here I actually do mean 100 gram. There's a difference. Let me show you the difference. Look carefully. The space, yeah. So this is 100 multiplied by 9.81. and this one is 0.100 kilogram. Space matters.
Please write GM instead of grams, then it will become more easy for us.
GM?
Yeah, you can write.
No. We'll just be careful with our space. Right. So, you can draw, and then I'll do it.
What meter?
A meter stick is 1 meter.
No, it's stick, not stick.
Oh yeah. Sorry, yeah. It should be a 1 meter stick, not a stick. Yeah. Yeah. I didn't notice that last year. Yeah, a 1 meter stick. And the first string is at 25 centimeters, and the second string is at 90 centimeters. I want you to draw this. So, draw, please. Yeah, that's it, like this, yeah. What word are you checking?
Thing.
Which one? Ah, okay.
So, if we join with gram, so it will be 0.01 kg.
0.1.
Okay, 0.1.
Did you draw it, Adnan?
I think so.
What word?
Still.
Which word?
Oh. I don't know what is string.
That's okay.
What is that?
You know now? What's another word for string? Rope?
Yeah.
Yeah.
Do we have... Do we have something that's like a string? Here. This is a string.
Very small.
Yeah.
Yeah.
Yeah, a small rope, yeah.
You know the guitar. The string.
Yeah.
The best one.
See, oh yeah, I saw you with your guitar.
Well, suspend.
Ah yeah, what's that word? Suspended. Now that's a difficult word.
The
Hanging.
latak.
Hanging, yeah. So like here,
Yeah.
this is suspended. Hanging, yes. Right, so then you should draw it perfectly then. What does it look like?
I don't
I don't
know.
know.
So it's like
Nearly.
When she asked, I came up to my mind.
Huh?
He knows it, but he don't know. He forget it.
Alright, fine. Okay, look. So this is the 1 meter. This is the 1 meter. And then what you have is a string here and 1 here. And I said here to here, this is at the 25 centimeters. And what did I say this one was? 90 centimeters. And what did I say the weight was?
100 gram.
So this is 0.1 G. And where is that? Yeah, so what number would that be at?
50.
50 centimeters. You understand?
Oh, you have to, okay.
It's in the middle. Yeah, okay. So draw this if you didn't draw it.
No, but why 50?
Because it's in the
Center
middle.
of gravity, it's the weight.
This is 1 meter.
Yeah.
The center of gravity is in the middle.
It should be 0.
50 centimeters.
50 centimeters.
Okay. So, this force, we don't know. I'll call it T. This force, we don't know. I'll call it S. I know, equation 1, T plus S should equal 0.1 G. Or in other words, T plus S should equal 0.981 newtons. Yeah, so this is my first equation. Now, do I have enough to find T and S? No, I need a second equation. So what's my second equation? What will I use? I can use the turning force, because the meter stick, look, is not turning.
It's not
It's balanced. It's not turning. Now, big question. where do you want the turning point? You can put the turning point like here, 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 or here. 0, 25, 50, 90, 100 centimeters. Where should you put it?
I think 25.
You agree 25, yeah. In fact, it doesn't matter where you put it. You get the same answer. So you should pick the easiest place. Why should we pick this place?
Because it's easier or...
Why is it easier?
Just have the number there, so
Because
we
it
can
will-
count it.
Yeah. Because the t is already here, we can cancel the t because we don't count it. Why don't we count the t? Because it goes through the turning point. Remember, any force that goes through the turning point, you can forget about it. Right, so this one, will it make it turn clockwise or anti-clockwise?
Clockwise.
Clockwise. And this one?
Clockwise.
No, anti. Because it's gonna go around it like this. Whereas this one is going clockwise.
It's like that one.
Yes. Is that okay?
No.
Yeah. So, what is the turning force from this one? What's the distance? 0 point from here to here?
0.25.
25. And the force? 0.1 g. And then that should equal the other direction. So what's the distance now?
0.7.
Yeah, go on, do it in your head.
Do what?
The distance from here to here.
Oh.
0.5. First it was 0.5.
0.65.
So it's 0.25, 0.25.
No, but this first one is 0.25, true. And then from here to here. 65, isn't it? Yeah, 0.65.
I said that. You can hear it on the record.
Fine. 0.65 times, what's the force?
0.5.
No. What's the force here? Remember, it's distance by force, and the force is F. So equation 2 is 0.65 S equals 0.245. Right, easy peasy, because what does this formula give me? What can I get from this? I can get the S. And then exactly, and then I can put that in here to get the T. What do you call this problem in maths, when you did it in maths?
This is elimination.
Yeah, elimination, but what's these types of problems called?
Degree.
That's it, degree 2, yeah.
But it's not elimination.
It's not even elimination. What method is this that I used? Substitution. Yeah.
Elimination.
Yeah, because I practically had the S here anyways. Yeah. This is a very, very, very common section A question for a physics exam. You know, it's very basic, or not basic, but a very typical physics question in the exam, especially like a short section A question will be exactly something like this, where they want the two forces in the strings. Yeah. The only way that they make it a little bit different is instead of having two strings, they have two like legs on a table. But I mean, it's still an or and an S, so I mean, there's not really any difference. Which we'll see, anyways. Okay, so one more example to do, and then we'll finish. Okay, so last example. Again, you can try and read it, and then you can read it and try to draw it. Beam, yeah, what's a beam?
Yeah, it's the metal one. They're used in the house to build a house.
Yeah.
Ceiling.
H-beam.
Yeah.
They see, they know a lot about things. I'll try and draw it for you. This is a beam.
Used to make in the houses.
Used to build homes, yeah. Yeah, so you can just draw it like this. Just no need to make it fancy. Okay, so this is our beam. Right, so we have two men, and they're able to carry this 50 kilograms beam. The beam is 3.6 meters long, so from here to here is 3.6 meters. The center of gravity is 2.1 meters from the end, so like here, this is, sorry, let me make that a bit clearer. This is 50 G. Now, this distance I said in the question is 2.1 meters. So then this distance here, if the total is 3.6, must be 1.5 meters
3.6.
minus 2.1.
Yeah.
50, yeah.
Okay. The first man is 10 centimeters from the end of the beam. So there's a man here. And this distance is 0.1 meters. And then there's another man here. You get the idea. And we do not know where he is. So we'll just call this distance here, we'll just call it x. Okay? But there is one other thing you know about this man that's actually important to the question. What do you know about these men? Identical twins.
So
You know twins?
Selma.
Yeah? So, yeah, if they're the idea in my question was if they're identical twins, then it means that they're the same strength. Yeah, so what I wanted you to try and figure out is that this F is the same as this F, yeah, if they're the identical twins. Right, so let's see what equations we can make. So my first equation is 2F equals 50G. Well, that's great because that gives me the F. 245.3 newtons,
Yeah.
roughly.
245.
But the F is not what I want. I want the X. So, where should I make the turning point to use turning force?
Could it be anywhere?
It could be anywhere, so where would be the best place to use it?
Negative 1.
Yeah, maybe 0.4.
I kind of feel like it might be easiest to put it here, because then I can say this turning force equals this turning force, and I already know the F. So I think I'll do that. Okay? What is this distance? 2. Yeah, because 2.1 is from here to here, so this is 2. And then what is this distance? Now, be very careful, this distance is, anybody?
1.5.
Very good, 1.5 minus x, very good, okay. So we have 2 times F should equal 1.5 minus x times F. Is that right? Like this. Yep. Okay. Well, that's actually nice. I didn't even need to find the F because they actually cancel. So I get 2 equals 1.5 minus x.
2 plus 2 minus 1.5 is
0.5. No. Yes. No. No, x. Oh, no. I made something wrong with my question.
Minus 0.5.
So that means he's standing here. 0.5 out. Okay, I made a mistake in the question, because you can't be standing out there. The minus means it's going backwards. So, he's back here. The x minus 0.5, rats.
Let's just change the sign.
Change, the result of 3.6 meters.
Make it longer.
Yeah, 12.1.
If I make it longer, the problem is this number, the 1.5, isn't it?
I will have to do it all over again, but
No.
X minus 1.5.
it would make sense. But
Huh?
X minus 1.5.
No, it's 1.5 minus x is right. No, just make the beam longer.
Yeah.
How much longer do I need to make it? I'll make it an
4.4.
extra meter longer, maybe.
Mm.
If I make it for 4.6, how would this change? This would be 4.6. So what would this be? This would be 2.5, and this would be 2.5. This would be 2.5, 2.5. And now it's positive then. Yes, okay. All right, so just change the 4.6 to question then. That's better. Okay. So the key to these questions is really about making two equations, really. And the first equation is usually the up forces equal to down forces, and the second equation is the clockwise turning force equals the anti-clockwise turning force. So this should remind you of the lesson in maths degree 2 systems, really. Yeah. Okay, so let's see. We'll change that to 4.6 after lunch. Okay.
Can you show us the drawing, please?
Really? Yeah. That's it. The in green is what I changed, so that's 2, 2, and 4 now. Yeah. Yeah. Okay. So here is the homework.
Oh.
Yes. Yes.
we can't log it. Yeah, we'll find it on YouTube.
I'll fix it after
Find it on
lunch.
YouTube
Just take a
anyway.
picture.
It'll be on my YouTube channel after lunch, anyways.
I don't like.
It's easier to take a picture because
I know.
get it done so
I
easy.
know.
That's it.
Yeah. Okay. I'll try and fix the Moodle accounts after lunch. I don't know what happened. Maybe someone hacked it. I'm not sure.
Oh,
Someone in our class.
Yeah.
what does it mean?
Yeah. All right. We'll leave it there. Did you want to take a picture of this? This is the homework then. You got it? Okay.
Thank you.